3 simple chemistry experiments. Yeah, about crazy stuff. Do you know how antifreezer helps the radiator to preserve liquids in actual liquid state during winter? This is where the determining the freezing point of these solutions and antifreezer experiment comes in.
In this experiment, we use 3 types of dissolutions: distilled water, ethanol glycol in 10% of water, and ethanol glycol in 20% of water. We use an ice bath to diminish the temperature of the 3 dissolutions. We noted that high percentage of ethanol glycol in this dissolution means that the solution is resistant to low temperatures. Commercial antifreezer contain less than 10% of ethanol glycol, enough to disrupt hydrogen bonding when dissolved with water.
That's why the water in the radiator do not freeze even at temperatures below zero. For example, a 60% ethanol glycol with 40% water dissolution freezes at minus 45 degrees. The second experiment relies on the fact that temperature and concentration can affect the rate of a reaction. We make a redox reaction and monitor the advance of it with an indicator. Kinematic in chemistry studies the velocity of chemical reactions. This means the time in which the reactives turns into products.
We prepared different solutions containing vitamin C, iodine, and hydrogen peroxide. Each solution was tested under different states in order to observe the effect of concentration and temperature over the velocity of the reaction. We used a stirring machine and magnetic peel for this. We find that if the concentration of one of the both reactants was bigger, the reaction will take less time to happen, but if both were balanced, the reaction to happen will take a little bit longer. We realized that the reaction had happened when the color in the solution was changed.
That's why vitamin C helps our body as an antioxidant, protecting us from free radicals.
That last experiment was pretty cool. Did you know that different elements can produce specific colors? This easy but fascinating experiment lets you visualize how electrons gain energy and how they release it in a photon. We use a porcelain plate to place 10 drops of different dissolutions containing 6 different elements, including potassium, barium, calcium, strontium, and copper. Using a nichrome handle, we placed each solution over the Bunsen burner. The effect was amazing.
We found that potassium produced violet, sodium orange, barium yellow, calcium red, orange, strontium red, and copper blue-green. This happens because the electrons of these elements jump into higher state orbitals, and when coming back, they produce a photon with a specific wavelength. We hope that you enjoyed these experiments. See you next time!
Created using Powtoon.